Section 1.3, Complex Numbers and Simplifying Radical Expressions. We are going to start this section by reviewing the perfect squares and perfect cubes that we talked about when we went over factoring. So hopefully you remember a lot of these. I'll give you a moment to write down the numbers in your notes. The numbers that you are writing are called perfect squares. So they include 1, 4, 9, 16, and so on. If you can memorize these numbers, that would be great. So when we start talking about square roots here in just a moment, you could see the number 225, for instance, and know that the square root is 15 right off the top of your head. Write down as many as you can without looking at the slide. And while you are writing, let's also recall that variables are perfect squares when the exponent is a multiple of 2, or you could think of it as the exponent is even. So x squared, x to the 4th, x to the 6th, and so on are also considered perfect squares. Perfect squares are very special. We use them a lot in math. If you're not finished writing, you can always look back at the PowerPoint, or of course you can use your calculator or work these out by hand if you need to. Here's a list of perfect cubes. This is a shorter list. I won't expect you to memorize beyond 6 cubed, but I would like you to know 1, 8, 27, 64, 125, and 216. When you see those numbers, be able to recognize them as perfect cubes. And variables are perfect cubes when the exponent is a multiple of 3. So x cubed, x to the 6th, x to the 9th, and so on. So these are all perfect cubes. Okay, so next we're going to talk about properties of square roots. The first property says every positive real number has 2 square roots, one positive and one negative. For example, the square roots of 25 are 5 and -5. Now let's think about why both of those are square roots of 25. We know that to be a square root means that you can take that number times itself to get 25. So if we were to do 5 times 5, that's equal to 25, and that's why 5 is a square root. But notice -5 times -5 is 25. Therefore, -5 is also a square root. Or you could think of it instead of 5 times 5 as 5 squared, or -5 squared. So the square roots of 144 are 12 and -12. 0, of course, only has one square root. The square root of 0 is 0. And then look at property 3. It says we use a symbol called a radical to denote the non-negative. So in other words, the 0 or positive square root of a real number. This non-negative square root is called the principal square root. So if we were only giving the principal square root of 25, it would be 5. So here's the notation. Look at these equations at the bottom. If you see that radical symbol and it does not have a negative sign in front of it, you only give the positive square root. And the second equation shows us if there's a negative in front of that radical symbol, that negative just carries over. And so you would answer -5. Negative, and then the square root of 25 is 5. Property 4. The number under the radical is called the radicand. I'll be using that term some, just so you'll know what I'm talking about. And property 5, for any real number c, such that c is greater than or equal to 0, the square root of c squared equals c. Now, that may be a little hard to understand with all those c's, but look at the examples. The square root of 5 squared equals 5. Now, I'm going to go ahead and show you why it works that way. Now, this requires a few things that we haven't studied yet, but to square something means to multiply it times itself. And then we're going to learn a little later on that to multiply radicals, you just multiply what's underneath. So 5 times 5, and you keep it under the radical, and then we know square root of 25 is 5. Remember, the radical symbol, we're only giving the principal square root. So property 5 is saying it's not necessary to go through all of that. When you're squaring a square root, you will always just get the radicand. So you get just the 5. It's kind of like the square and the radical symbol cancel each other out. So here's a second example with a decimal. It doesn't matter what the number is that's in the radicand. This property will always work. Here's a few examples before we do some more properties. Number 1, we want the square root of 196. So if you memorize that list of perfect squares, then you'll know right off the top of your head that the answer is 14. Because 14 times 14 is 196. Notice when I write my answer, 14, I do not write the radical symbol. Taking the square root causes that radical symbol to come off. Also, I am only giving the positive square root because my radical symbol does not have a negative sign in front of it, then it only wants the positive. Now, number 2, it does have that negative. So you're going to keep that negative and then take the square root of 16, which is 4. The radical comes off, and our answer is just -4. For example 3, we need to think about property 5. So rather than having to work it out, if we know that property, then we know that squaring the square root is just going to leave the radicand. So our answer is 2.9 without the radical symbol on it. Fairly simple examples, but little details that you need to learn. Here's 2 more properties. Property 6 is saying that when you have a number directly next to the radical, it means multiplication. So a square root of b means a times the square root of b. You do not have to have a multiplication symbol. It's kind of like the radical is like a variable. When I write 5y, then it's understood that's 5 times y without writing a multiplication symbol. Property 7 says the square root of a plus the square root of b is not equal to the square root of a plus b. So for example, if I had square root of 2 plus square root of 3, it does not equal square root of 5. And that's a hard one for students a lot of times. It's tempting to want to add the radicands together, but it just doesn't work that way. You can use your calculator and find the decimals, and you'll see that the decimal for square root of 2 and the decimal for square root of 3 added together does not equal the decimal for square root of 5. So if you ever forget, that's one way to determine that they are not equal. It works for multiplication, and we'll see that again a little bit later. We can multiply the radicands together. We just can't add them. Again, it's like variables. Adding square root of 2 plus square root of 3 is kind of like trying to add x plus y. They're not like terms. They cannot combine. And then look at the note. It says the answer to a principal square root should always be positive. So anytime you see this symbol, the answer must be positive. So we'll do a few more examples. Number 1, we could use property 5. However, the answer is not -7 because of what we just noted on the previous slide. We have a positive radical symbol. We cannot give a negative answer. So probably the easiest way for you to see that is to go ahead and square the -7. So -7 times -7 is positive 49, and then take the square root, which is positive 7. Number 2. Here again we have property 5. The square root and a square are going to cancel each other out and leave us just the m. Now, when you have a variable, we do not know whether it's representing a positive or a negative number. However, we need it to be positive because of our radical symbol. So to make it positive, we are going to put absolute value bars on that variable. Now, absolute value is always positive, so that's how we make our answer positive. Number 3 is very similar. So you have a whole expression here, but it has a variable in it. And because of the variable, we don't know whether the result would be positive or negative. So we're still going to write the 2x plus 3. The square and the square root get rid of each other. It leaves the 2x plus 3. But to make it positive, we're going to put absolute value bars. We didn't need absolute value bars on number 1 because 7 is already a positive number. Number 4 goes back to property 6 that says a number next to a radical means multiplication. So on the next step, we're going to keep the 5. We're going to square root the 9, but we're going to need a multiplication symbol. We could use a dot or parentheses because that radical comes off when we take the square root. And we don't want to just sit the 3 right next to the 5. It would look like 53. But we multiply 5 times 3 and see that the answer is 15. Examples 5 and 6 will show us how property 7 is a true property. So on number 5, we have an operation to do that is under the radical. So you should go ahead and do the operation underneath. It's kind of like working inside the parentheses first. So we add the 36 and 64, we get 100. And then we square root and get the answer 10. Now look at number 6. If we square root the 36, we get 6. And we square root the 64, we get 8. We're square rooting them separately because they each have their own radical. The addition is between the radicals. And then we add those together. The answer is 14. Therefore, the square root of 36 plus the square root of 64 does not equal the square root of 36 plus 64. Again, that was property 7 that we looked at. We're going to do 2 more examples here before we go on and talk about complex numbers. These 2 examples are getting you ready to use the quadratic formula. We will use that to solve quadratic equations, and in using that, you will substitute numbers into the formula, and it'll look something like what we see here on these examples. What we need to learn is how do we simplify that? So again, think of the radical like parentheses. You have to do what's inside it first, and then you would take the square root at the very end. So we're going to keep that big radical. Now, under the radical, we have an exponent, we've got multiplication. We're going to do the exponent first. -5 times -5 is positive 25. And at the same time, if you want to, you could go ahead, let's bring down our minus sign, and we'll do left to right on the multiplication. We've got 4 times 3 is 12, and then we'll bring down the times 2. Now I've got subtraction and multiplication. I need to do the multiplication. So we've got 12 times 2 is 24. And now we subtract. And last, we take the square root. The square root of 1 is 1. Let's try another one. Actually, I'm going to give you just a minute to try this one on your own, and then I will work it out. Okay, let's see how you did. -1 squared means -1 times -1, which is positive 1, minus, and I'm going to go ahead and do the 4 times the 6 is 24. Bring down the -2. Then I need to continue with the multiplication, so the 1 comes down. Now here I think of this as negative times negative, so it's a positive 48. Very important that you get this sign correct. Now we add, and the square root of 49 is 7. Okay, I'm going to stop there, and we will continue these notes in another video.